Welcome back to James's Physics 101. Today, we're diving into reality's biggest glitch, the double slit experiment. It sounds simple. Fire some particles through two slits and see where they land. But the results? They changed everything. Imagine firing marbles at a single slit. They pass through and form a single band on the back wall. Makes sense, right? With two slits, you get two bands. This is exactly how we expect solid matter to behave in our everyday world. But what about waves? Think of ripples in a pond. When they hit one slit, they spread out in a circle. When waves hit two slits, they interfere with each other. Where peaks meet peaks, they get stronger. Peaks meeting troughs cancel out. This creates an interference pattern, a signature of wave behavior. Now here is where the quantum weirdness begins. What happens if we fire tiny bits of matter, like electrons, through those two slits, one at a time? We fire them individually. They hit the back wall like tiny solid particles, one dot at a time. But as thousands of dots accumulate, something impossible happens. They form the interference pattern. How? Each electron is fired alone. It has nothing to interfere with. Does it somehow go through both slits at once? Physicists call this superposition. Before it hits the wall, the electron exists as a wave of probability. Naturally, we wanted to see which slit it actually went through. So, we placed a detector to watch it. And that's when the universe glitched. As soon as we watched, the electrons stopped acting like waves. They went back to acting like little solid particles. Two slits, two bands. No interference pattern. The mere act of measuring, of observing, changed the physical outcome of the experiment. This is called wave function collapse. Observation forces the universe to pick a definite state. Turn the detector off, and the weirdness returns. The universe seems to behave differently when we aren't looking. This suggests that at its most fundamental level, reality isn't made of stuff, but of possibilities. Large objects like us seem solid, but they are built from these elusive wave-like quantum building blocks. As Richard Feynman once said, if you think you understand quantum mechanics, you don't understand quantum mechanics. The double slit experiment remains the heart of quantum mystery. It tells us that we are part of the equation. And this is just the beginning. Next, we'll see what happens when we put a cat in the middle of this mess. If you enjoyed this quantum deep dive, make sure to hit that like button and subscribe to James's Physics 101. Keep questioning, keep exploring, and stay weird. See you in the next lesson.